Hello dears, now we will be learning about spectrophotometry. Coming to the introduction, spectrophotometry, it is a method or a technique in which absorption or transmission properties of a material is quantitatively measured as a function of wavelength, while spectrophotometer is the instrument or the equipment which we use to do this technique of spectrophotometry. So spectrophotometer, it is an instrument which measures the light absorption as a function of wavelength in the UV as well as visible regions. So the amount of the light absorbed is measured by this equipment known as spectrophotometer, and the technique it is known as spectrophotometry. And this technique follows the laws of light absorption, that is Beer-Lambert's law. Unlike colorimeters, in spectrophotometers, the compound can be measured at precise wavelength. In colorimeters, we can measure only a range of wavelength, while in the spectrophotometers, we can measure at the precise wavelength. A spectrophotometer measures the amount of photons absorbed by a sample after it is passed through its solution. With the spectrophotometer, the amount of a non-chemical substance can be determined by measuring the absorbance. By measuring the absorbance, we can calculate the concentration of the substance or solute or a compound present in a solution. Coming to the principle, the basic principle behind this method is that each compound absorbs or transmits light over a certain range of wavelength. And this equipment works under the principle of this Beer-Lambert's law. The spectrophotometer technique is to measure light intensity as a function of wavelength. It is done by diffracting the light beam into a spectrum of wavelengths, detecting the intensities with a charge-coupled device and displaying the results as a graph on the detector and then on the display device. That means the spectrophotometer diffracts the light beam into a spectrum of wavelength, into its component wavelength, and detects the change in intensity or difference in the intensity of the transmitted light which is detected by the charge coupled device, and the results can be obtained as a graph on the detector, or we can measure in the display device. In the spectrophotometer, a prism or grating is used to split the incident beam into different wavelengths. The incident beam of light is split into its component wavelength by the prism or grating present in the spectrophotometer. By suitable mechanisms, the waves of specific wavelength can be manipulated to fall on the test solution. The range of wavelength of incident light can be as low as 1 to 2 nanometer. The wavelength range can be adjusted manually of a very short wavelength also. The spectrophotometer is useful for measuring the absorption spectrum of a compound, that is, the absorption of light by a solution at each wavelength. The amount of light absorbed by the compound can be measured, or the amount of light absorbed by a solution at each and every wavelength or each and every nanometer of the spectrum can be measured using this spectrophotometer. Then coming to the different types of spectrophotometer, mainly there are two types of spectrophotometer, that is single beam spectrophotometer and double beam spectrophotometer. In the single beam spectrometer, it is used to measure the intensity of incident light. The sample must be removed so that the reference can be placed each time. This type of spectrophotometer is usually less expensive and less complicated. That means in single beam spectrophotometer, the only one slot will be there for placing the sample or to place the reference cuvette. So each time we have to remove the sample to place the reference. So it is a tedious job, and it is less complicated and less expensive. While in double beam spectrophotometer, there is two slots for keeping, one for keeping the reference cuvette and one for the sample. So it is less tedious when compared to this single beam spectrophotometer, and highly expensive also, and its accuracy is very high when compared to the single beam spectrometer. So in double beam spectrometer, before it reaches the sample, the light source is split into two separate beams. So the incident light is split into two separate beams, and one beam passes through the sample and one beam passes through the reference, and the difference in the intensity is compared there itself, and we can we can get the result more accurate than single beam spectrophotometer. So this gives an advantage because the reference reading and sample reading can take place at the same time with the same beam, which is divided into two separate beams. And here is the figure which depicts the working of single beam and double beam spectrophotometers. So here we can see the light coming from the source is directed by the collimator into the prism or grating, which directs the light into the slit. So the wavelength is selected from here, and so